Hello and welcome to the video. Today we're going to be going through a common story problem that's used in differential equations. In this instance it's a mixing problem, and so for this one in particular we have a large tank that is partially filled with 100 gallons of fluid with 5 pounds of salt dissolved within that 100 gallons. Then we have brine that contains half a pound of salt per gallon that is being added to this tank at a rate of 10 gallons per minute. Then we have a solution in the tank that is also being pumped out, and this rate is at 8 gallons per minute. And we want to know how much salt will be in the tank after 60 minutes. So first, let's write down some of the known information. So we know that the tank starts with 100 gallons. And we know that it starts with 5 pounds of salt. And then we also know the rate in and out. So our rate in, is with the brine, which is 10 gallons per minute. And then the rate out is the solution at 8 gallons per minute. And then our brine contains half a pound of salt per gallon. Okay, so with some of that known information down, let's get right into how we set up our initial differential equation so that we can solve to find this amount of salt. So basically we have a dA over dt will be equal to the rate in minus the rate out, where A of t will be equal to the amount in the tank. So for our rate in, we have all the known information to find this. And that would be, we have 10 gallons per minute going in of brine, and then that is multiplied by half a pound of salt per gallon. So times 1/2. And the gallons will cancel. So we end up with our rate in of 5 pounds per minute. So we have 5 pounds of salt entering the tank per minute. For the rate out, we don't have all of the information that we need quite yet. We do know that the solution is being removed at 8 gallons per minute. So we have our 8 gallons per minute, and then this will be multiplied by our solution amount. Now notice the brine versus solution difference. So the solution, we need to include not just the brine that's been added, but also the initial amount that we were given. We have to include that as well. So we'll have some unknown amount at a given time divided by our initial amount, which is 100 gallons. And then we need to add to it whatever the difference is between the rates. So we know the rates over here, so we have our rate in minus our rate out. So if we do 10 minus 8, we get a difference of 2. So we are gaining 2 gallons per minute. So I want to add 2 times some t, which is our time. So with this, we can plug in our rate in and rate out to find our differential equation. So now I have the change in amount over the change in time is equal to 5, which will be pounds per minute, minus our 8a of t, multiplying that into the equation there, over 100 plus 2t. We can simplify this by pulling out a 2. So if we do that, we have dA dt is equal to 5 minus, so if we pull out our 2, we'll have 4a of t over 50 plus t. And at this point, we can now try and solve for the amount a of t. To do this, I want to move this to the other side. So I will have the change in amount over the change in time is now not equal, but added to 4 over 50 plus t, a of t, and that's equal to 5. And if you notice, we have an a on top and an a here, so this is linear in a. So the next step is always our integrating factor whenever we have a linear equation. So I will do this off to the side and denote it as IF for integrating factor. And remember, we will have rho of x is equal to E integral and then P of x dx, where P of x is going to be whatever's in front of our linear variable, but in this case it'll be a function of t instead of x. So we'll have rho of t is equal to E integral of what's in front of our a, because that's our linear variable. So 4 over 50 plus t dt. And if we integrate this, we find that we get e raised to the 4 natural log of 50 plus t. Moving the 4 up into the exponent, we can then cancel the natural log in e, and we are left with 50 plus t raised to the 4th power is equal to our rho of t. Now that we have our simplified integrating factor, we need to multiply this by both sides of our equation. So if we multiply by rho of t, we find that the left-hand side will become the derivative of two functions, and those two functions are 1, your integrating factor, and then 2, your linear variable. So I will have d over dt, and our integrating factor for our first function, 50 plus t to the 4th, multiplied by a of t for our second function, which is our linear variable. Then on the right-hand side, we just have our integrating factor multiplied by whatever we have on the right-hand side. So in this case, we will have 5 times 50 plus t raised to the 4th. And now that we have that, I want to integrate, so I'm going to multiply by my dt on both sides to get rid of that. And then if I integrate, my d and my integral on the left-hand side will cancel, and we're left with just what's on the inside, which should always be the case. So we have a 50 plus t to the 4th, a of t. And then on the right-hand side, I need to integrate this. So if I do 50 plus t raised to the 5th plus c, notice that we would just use a chain rule here, but the derivative of the inside is just 1. So therefore, we can just add 1 to the exponent and pull the 5 up. And then we have plus c. So now what I want to do is I want to find this constant c while it's by itself. So to do so, we remember we're looking for the amount of salt. So the initial condition that we need to use is not the amount of fluid we have, but the amount of salt. So a of 0 will be 5 pounds. So if I bring this down, a of 0 is equal to our 5 pounds of salt. So I'm going to plug 0 in for all the t's. So I will have 50 to the 4th times my a of 0, which will be 5, is equal to 50 to the 5th, because t will be 0, plus c. And if you simplify this by multiplying through and then subtracting this over, we'll find that c is a rather large number at negative, or excuse me, very small because it's negative, of 28125, and then 0, 0, 0, 0. So that will be our value of c. Grabbing another page to continue on here. We will plug in our value of c into our equation, into our simplified equation here. So we have 50 plus t to the 4th times our amount, a of t, is equal to 50 plus t to the 5th, and then minus our c, because it's negative here, 28125, 0, 0, 0, 0. And then after that, we want to get a of t by itself, because we're looking for, remember, a of 60 minutes is equal to some unknown amount of salt, and that's what we want to find. So let's get a of t by itself. So if I divide through by 50 plus t to the 4th, we then have a of t is equal to 50 plus t, and then minus some big number here, 125, 0, 0, 0, 0. And then we want to plug in our value for t. So a of 60 is equal to 50 plus 60 minus 28125, 0, 0, 0, 0, divided by 50 plus 60 raised to the 4th power. And if we do this calculation, we find that A of 60 comes out to be 108.1 pounds of salt. And then that is our answer.